Welcome back to the Hyperbolic Coding Chamber. We are back once again. The cycle of life and death continues. General destruction, death, displeasure. Things are going fine. I think my sleep schedule is just trash. It's interesting how much everything else has to do with just staying focused on one thing. So, hoping to fix that schedule this weekend. Maybe we can figure out something for it to stay fixed. But I don't think that's possible because the sleep schedule has just kind of always been this way. It's definitely gotten better over the years. I typically stay awake until 3 a.m. Something about the nighttime is really when things start to flow, and probably has something to do with the things just kind of getting simpler after that time. There's no cars out on the road. You're just like, the environment quiets down. Everything just pretty much becomes quiet, which is pretty useful. That being the case, we're down for our classic 30-minute Friday session. So I think that's what we're going to do today. We've been receiving a lot of support from the Discord, which has been pretty dope. Particularly, few pews helped me out with the heap implementation. But I think at this point, we might just have to save the heap for when it is required of us. And then in that case, we'll just bust out the Pythonic daemon. But in another case, we're probably just going to keep using JavaScript and TypeScript. So maybe that's where we're at. Maybe that is where we're at. But yeah, my brain is absolutely fried. That being the case, every time I've said that, we've had an awesome session. So maybe there just goes something to say about ignoring my own feelings about how a session is going to go, and to just try the session and actually see how it goes. But that's where we're at. I typically don't say too much on Fridays because we're usually strapped for time, and this Friday is no different. So yeah, I think that's what we're gonna do. 30 minutes, 30-minute grind time. We're entering the Coliseum, and yeah, I'm excited to get more problems done. And yeah, there's definitely some kind of flow to LeetCode that we're in now with the easy problems, and I can definitely see why some people, why it can be found fun. I'm definitely at the point where I think it is kind of fun, but maybe that'll change when we get to mediums. So, but I was watching a show recently, and there was a scene where they were trying to complete a chain of events, right? But not everything in the chain had a chain to something else, and what it really was a directed graph. And I started thinking, I was like, wait, the algorithm they're trying to use to complete the chain, I started thinking about it in LeetCode terms, and I was like, oh man, I become one of those people. I'm that person now. So that was pretty cool. So I think somehow we're intuiting the concepts, because that was a graph problem. Oops. That was a graph problem, and I think the solution they were looking for was actually, I'm not certain, but I think it was a topological sort. But yeah, so that's currently where we're at. So that's what we're gonna do today. Not gonna do that problem. That'd be a cool video. What we're actually gonna do today is just do some LeetCode. So that's where we're at. And if you're interested in something like this, you should definitely join the Discord. We await the moment once we finish all the easies. That'll be a celebration day. And yeah, so let's just jump into it, since we are a little bit strapped for time. So I'm going to set up the classic torturing time, the torturing chamber for time. And we had a lot of good we actually had some pretty cool problems yesterday. So here we are. I think we did count good triplets, and there's actually a lot of cool solutions to count good triplets. And I don't think we did first letter to appear twice yet, so we're going to try that. So given a string S consisting of lowercase English letters, return the first letter to appear twice. A letter A appears twice before another letter B if the second occurrence A is before. Looks like we could probably do this in linear time, constant space. And I think the first step would be just shoving everything into a map. And then we create a map of string to number. From here we can do for const letter of S, and we'll load pretty much every letter into the map. And then from here, what we can do is do for const letter. Actually, could do it in one pass. We'll just say if couldn't I compress these lines? I've never actually tried it. But couldn't I have just done something like this? And the whole thing could be compressed to set letter. And then you can just do if map dot get letter equals 2. So that was definitely one of the simpler ones. So we won't look too deeply into that one. We have backspace string compare given two strings S and T, return true if they are equal when both are typed if they are equal when both are typed into empty text editors. Pound means a backspace character. Note that after backspacing an empty text, the text will continue empty. So AB, pound symbolizes a backspace. C, and we have AD, pound is a backspace, so we get C. I think we could just use a stack for this, but the question is to use one stack or two stacks. It feels like we could probably just use two. So if we make the first stack an array of characters, also make a T stack, which is a for const letter of S if letter equals pound, right? And stack dot length is not equal 0, right? Then we'll do stack dot pop. We'll do S stack dot pop, else we'll do stack dot push letter. Okay, my whole screen is frozen. sstack.push. And then we'll do the same thing except change this to tstack. And then I think we should just be able to return sstack.join equals tstack. Looks like we're getting into the simpler easies. Maybe that's why we're cutting through these. A lot of the harder easies were at the top. Oh, well, we can't do else. But we can't do it like this. We'll just wrap it. I'm pretty sure if you stack dot pop an empty array, I don't think that throws an exception. Or maybe it does. I have no idea. She gave us the same answer, but the else case we wouldn't add an extra character. So that was my bad. And I think we might have skipped one. We have rank transform of an array. Given an array of integers r, replace each element. An array of integers r, replace each element with its rank. Replace each element with its rank. We have an array of numbers, replace each element with its rank. The rank represents how large the element is. The rank has the following rules. Rank is integer starting from 1. The larger the element, the larger the rank. If two elements are equal, their rank must be the same. How many numbers are there? 10 to the 5. So it looks like we could, one way we could do this is we could load all the elements. We could sort all the elements, and then once we sort them, we could load their ranks into a map. And then from there, we could iterate through the original array and then assign each element its rank. One upside of this implementation is that the way we handle duplicates is easier. It's simpler. So we would copy the array. Then for the copy, we'll sort it. In descending order. And then from here, now we'll create the map. It's going to be from of order to rank. And we'll just say copy, right? If the map does not have a rank for it, right, then what we'd like to do is map.set num And I think this should work. Or maybe not. Oh. Wait a second. Oh, I did descending order. Rank is entry starting from the larger the element, the larger the rank. If the element, oh, so it should be sorted in ascending order then. Bro, my brain is so tired. I should have gotten more sleep. We have most frequent even element average. Yeah, I think we might have. It seems like a lot of the easies left are too simple. Now you have most frequent even element. Given an integer array nums, return the most frequent even element. So we could load all the elements into a map, and the only elements that we'll put into the map will be a mapping of key of number to occurrence, and then from there, the only numbers that we'll put into the map will be the even numbers, and then we can sort the map. You can cast the map to a tuple, and then sort the tuple based off occurrences. And then we'll sort it in descending order, and then we'll take the first one if it's the greatest or the smallest one of the two. It could be a three-way tie. So there could be an n-way tie. There could be an n-way tie. We can just have another stage where we load it into another map. Then we can return the last element in that map. So to do that, we have for const num of nums. If num mod 2 is equal to 0, right, then we know we have an even number, and then we'll say map.set num equal to, if the map already has a value for num, we'll get that value, add 1 to it, otherwise we'll set it to 1. So once we load it all in, we could have kept track of the maximum value. And then once we get here, we can basically just say we'll say the candidates, which is going to be an array of tuples is going to be equal to the map spread into an array, which is going to give us an array of tuples that we can filter based off these tuples, and we'll only keep the ones where the tuple value is equal to max awk. Then we'll sort candidates in which one do they want? If there's a tie, return the smallest one. We want array nums, return the most frequent even element. If there's a tie, return the smallest one. So we want to sort it by the key value. And then what we'll return is if candidates.length equals 0, we'll return -1. Otherwise, we'll return candidates sub 0 sub 0. So we filter out the ones that aren't equal to the max occurrence, and then we sort it by the keys, so smallest to greatest, and then we should be able to choose the first one. If there's no candidates, we'd return -1. So maybe this would be, I'm thinking this would be n log n because of the sort, but also linear space. So here we're given the root of a binary tree, and we want to return the average value of the nodes on each level. Average value of the nodes. Root of a binary tree, return the average value of the nodes on each level in the form of an array. Answers within 10 to the -5, the actual answer will be accepted. So we'd get 3, 14, and like 8 or something like that. Okay, so I think we could just do a BFS on this, and then based on how we do the BFS, we can add some null values in to delimit when we've reached the end of a level, and we'll have that way we can keep the last level. Actually, we won't actually have to keep a list of the last level. We can just keep adding. Once we reach a null value, we'll know how many to divide it by to get to our output. So we could do, we're going to have an array called output, which is going to be an array of numbers. It's going to be empty. We're going to return, we're going to need a queue, which we're just going to set to an array of root or null, and null is going to let us know when we're done. While the queue.length does not equal 0, we're going to say our node is going to be equal to queue queue.shift. We're going to have a value called sum, which is equal to 0, and count, which is also equal to 0. It'd be interesting to know, actually, I think there's definitely a way to know how many nodes are in a complete tree on each level, but I don't know. I don't think there's another way to do this without counting. So since the node exists, we're going to do count plus equal But there's two cases, right? Either the node exists, which means we have a node to handle, or it doesn't exist, which means it's the end of a level. If it's the end of a level, we're not going to do count plus 1. What we are going to do, though, is output.push sum divided by count. Notice that sum equal to 0, count equal to 0. And then we're already returning output. When we do have a node, we're going to say count plus equals 1 and sum plus equal node dot val. And then we're also going to do q dot push null if q dot length is not equal 0. So the reason we're doing if q dot length is not equal 0, because at the end, if there's elements still in the queue, if we're in this else case, it means we've already loaded all the next level of elements to be processed. If that's the case, we'd also like to know when to stop, so we need to push null. But if the queue is empty when we reach null, we don't want to keep going. And then in here we'll add if node dot left, then we'll do q dot push node. Nice. I didn't think this would work, so let's see if it does work on the rest of them. Nice. That's pretty satisfying. That's pretty satisfying. This would be linear time. Unfortunately, we don't actually have access to a deck, so this queue or the shift function is actually n squared. But if we actually had access to a deck, then it would be fine, I think. But that's pretty cool. That is pretty cool. Okay, they really did this with a DFS. This is crazy. Oh, that's actually really clever. You could do it with DFS. You just need something else outside of it that you can actually count the number of nodes at that level and also the sum at that level. Then you can also just return that array. That's really clever. And I guess we just did it the DFS way. I actually don't get this version at all. I'm not following how this is possible. Oh, they're just doing the same thing, so they keep a temp array. Yeah, that DFS version is actually really clever. That DFS version is definitely a flex. And yeah, so I think we'll probably stop there for now. And yeah.